All right. Section 8.1, we're now going to tackle tasks 3 and 4. Okay, so we're first going to learn about a new function called a step function. First of all, we're going to define a step function is constant over, I'm going to say, each interval. What we mean by that is over each interval of our domain, it's constant. For example, if I put in x's from 0 to 6, it stays constant at 5. So you end up with a bunch of just straight horizontal chunks of lines, which gives it its name, a step function, because those look like steps that you climb. You're climbing steps. Okay, so it's straight constant. So it's straight horizontal across each of its intervals on its domain. Okay, so for example, an example of a step function is what we call the greatest integer function. The greatest integer function looks like this. It almost looks like kind of the absolute value symbol. Absolute value, we're going to write over here, we're going to talk about in a little bit in the next section. Absolute value is these straight up and down lines with a variable or number in between. This one has like these little pinched out below it. So, and the symbol actually tells you what to do. What the greatest integer function does is it rounds it down. Rounds down to the greatest integer that is less than or equal to the number. So I just remember it's the rounds down function, which is sometimes why it's called a floor function. Which makes sense because here we have those little ticky marks on the floor. Okay, so it rounds down. So basically how that works is it's again going to round it down. So I'm going to go ahead and we're going to create a table for this function. I'm going to show you how it rounds down. It's going to round it down to the greatest integer. It's going to round down to the nearest whole number. Okay, so when I put in a 3, the nearest whole number to 3 is 3. Okay, but if I put a 3.5 in, it's going to round it down still to 3 because 3 is the biggest number that isn't more than 3.5. So if I put in a 3.7, it's again going to round it down to 3. Any number in between 3 and 4, it's going to round it down to 3 until I get to 4, and then it's going to give me 4. And any number slightly more than 4. So it always rounds it down to the nearest whole number. So one way of writing this function, if we're going to use our piecewise, is basically it's going to give me 3 for any x value in between 3 and 4. So we'd write it 3 less than or equal to x less than 4. Okay, and notice here this is equal to, because when I do put in a 3, I get out a 3. But once I get to 4, I get out a 4. So it's going to give me a 4 for any x's in between 4 and 5. And it's going to give me a 5 for any x's in between 5 and 6. Okay, so forth and so on. So the graph of this one is very interesting. Again, it is a step function. So if we go to graph it, okay, so if we go to graph it, I'm going to go ahead and I'm going to have every 2 be 1 just because my graph is kind of small. So then here would be 1, 2. So when I put any number again in between, and let's do what we did. We did any number in between 3 and 4 is going to give me a 3. So it really looks like this. But at 3, it gives me a 3. But once I get to 4, I need an open dot here because once I get to 4, it's going to come up here and give me 4 until I get to 5. Once I get to 5, it's going to come up here and give me 5. So the function looks close dot, open dot, close dot, like this. And then even negatives, again, do we see why this is called a step function? Okay, because it gives this stair-steppy look. Okay, so it always just rounds it down to the nearest whole number. Okay, so if I was to want to know what f of 1 I don't know, let's even do a negative. Negative 1.5 is, so I'm the floor function, negative 1.5. It's going to round it down to the nearest whole number, which the nearest whole number below negative 1.5 would be negative 2. So it's going to give me out a negative 2. It rounds it down to that nearest whole number, so it gives me that negative 2. Okay, so is how that step function works. So that's our greatest integer function. Okay, so this is one type of step function. There's other types of step functions we'll talk about later on, possibly in the practice. There's a ceiling function where you round up, but this is our rounds down function, our greatest integer function. Okay. This function is used quite often in real life situations when you don't want to have anything extra. You want to use up all that you have, so that you round down to the nearest. So like if you need, there are a lot of real life applications for this. Okay. So now let's go into task 4. Suppose you go to a used book sale where all the books are being sold for $3. We want to write a piecewise defined function that models the whole number of books you could buy with whole dollar amounts. So we want our function to tell us how many books we could buy if we have a certain amount of money. So I'm going to go ahead. So basically, my input is going to be money. My output is going to be the number of books I can buy. Okay, and we're only dealing with whole dollar amounts, like $1, $2. Okay, so I can have $0. I can't buy any books. If I have $1, I still can't buy any books because they're $3 a piece. If I have $2, still can't buy any books. But as soon as I get to $3, I can buy one. I can also buy one book if I have $4 and $5. But once I get to $6, I can now buy two. Okay, so we want to write a piecewise defined function. So it's going to have a lot of different pieces. So basically, here, I can buy 0 books if I have anywhere from $0 to $1. Okay, so 0 to $2. So I can buy 0 books. Again, this is my output. I can buy 0 books if my input is anywhere from 0 up to 3, but not including 3. So 0 less than or equal to x less than 3. Okay. Again, notice I don't include 3. It's just strictly less than 3. Now, for anything from 3 to up to 6, I can buy 1 book. If I have anywhere from 3 less than or equal to x less than up to $6, but not including 6, because once I have $6, I can buy 2 books. Anywhere from 6 up to what? $9, I can buy 2 books. But once I have $9, I can buy 3 books. For $9 up till 12. Again, I'm just going up by 3 each time because every $3 I can get 1 more book. Once I hit $12, I can buy 4 books. So forth and up to 15, ... I'm going to go ... to show that it keeps going in this pattern. Okay, so it keeps going up by this pattern. Okay, so now it's interesting. Now we want to do it using the greatest integer notation. So we want to use the greatest integer function notation. Okay, so we basically want to use this. We want to use this symbol up here, this guy, to rewrite this function. Okay, so we want to use this greatest integer. This rounds down. So we need to compare these values to these and how they work. So how do we do that? We take the amount of our input, so again, our function. Okay, so really, we want to look at that from my input to my output. So my standard input output, when I get into 1, I'd get out of 1. When I get into 2, I get out of 2. So here we're going by 3s. I have to take my amount of money and divide it by 3. So like if I want to know, okay, for example, I'm just going to do, okay, so if I have $25, okay, let's continue this table. If I have $25 and I want to know how many books can I buy, the number of books, I would need to take that 25 and divide it by 3. Okay, so I take 25 divided by 3. It's not a whole number. Okay, so if we go ahead and grab our calculator, 25 divided by 3, 8.3. Well, that 0.3, I don't have enough. I only have enough to buy a third more book. So I don't have enough. I can only buy 8 books. So I end up getting 8.3, but I have to round that down to strictly 8. So really what I'm doing is I'm taking my input, the amount of money I have, dividing it by 3, and then rounding down. Show how that's going to look at a function by rounding down. To denote rounding down, we use that little floor symbol thing. So my function is going to take the amount of money I have, divide by 3, and then round it down. Okay, so then we do the round down function. So my x divided by 3 is what's inside that function. So to determine the greatest number of books you can buy with $20, so again, I f of 20, I would take 20 divided by 3, and then round down. So we would take 20 divided by, I meant to do this. 20 divided by 3 is 6.66. So basically I would have 6.6 repeating, round down, which will give me 6. I can buy 6 books. Okay, and I'll have some money left over, but I can have money left over, but I can't buy 7 books. I don't have enough. Okay. All right. So